Annual grid investment in Europe and the UK is surging toward $120 billion as operators overhaul aging lines for the digital age. To manage this shift, operators are turning to battery energy storage systems, a market expected to reach $150 billion in value by 2030. To capture a share of that value, developers must rethink their revenue models and move away from traditional infrastructure strategies. Between 2023 and 2050, worldwide energy demand is projected to jump by 130%. We are generating more renewable power than ever to meet that demand, but these clean sources are overloading outdated transmission towers and legacy grid infrastructure. This bar chart illustrates the fallout. In 2024 alone, German operators threw away 9.4 terawatt-hours of renewable energy because the grid had no physical capacity to move it. Battery energy storage systems, or BESS, solve this bottleneck by holding excess power until the grid is ready. Driven by this need, installed battery capacity is on track to grow by 50% every year through 2030. While the physical need and market growth are accelerating, capacity alone won't guarantee profitability for developers. As more developers bring battery plants online, the traditional strategy for making money is collapsing under its own weight. As battery installations increase, the payout for ancillary services crashes. In Great Britain, these services made up 75% of total revenue in 2022, but by 2024, that share plummeted to just 20%. To survive this drop, operators are pivoting away from basic grid support and turning their batteries into high-speed energy trading assets. This pie chart projects that by 2030, energy trading will account for 75% of all battery revenues. Using AI and algorithmic tools to dictate these split-second moves can boost real-time profits by up to 35%. Success now depends on winning an algorithmic trading war, where fractional advantages in dispatch timing dictate the final profit margin. At the same time, the physical cost to manufacture these systems is lower than at any point in history. This step chart tracks hardware costs, showing a 55% drop since 2019. In early 2026, prices for key components fell below $100 per kilowatt-hour. However, these massive savings on the factory floor are frequently erased by aggressive administrative bottlenecks in the field. Strict fire codes and grid queues mean that connecting a battery project in Europe now takes between 3 and 7 years. Cheap hardware yields zero return if the assets sit in a regulatory queue. Successful developers use modular, standardized designs to accelerate engineering and bypass administrative friction. As renewable power becomes the default, the stability of the entire electric grid relies on immediate, large-scale flexibility. The developers who secure the lowest hardware costs through standard designs, while deploying AI to trade their stored power, will capture the majority of this $150 billion market. The transition is underway. Those who adapt their commercial and engineering strategies will build the grid of the future, while the rest are left waiting for approval.